Swayam Prabha. Digital India. Educated India.
Having looked at mixing, now we should look into transporting the concrete, and therefore, in this lecture 2 for the module 5, we shall be looking into ready mixed concrete, which combines actually mixing or at least part mixing and transporting together, and transporting concrete. So, outline of this talk or this lecture would be concrete production in terms of ready mixed concrete and transporting concrete. Right. So, what is ready mixed concrete? You see, ready mixed concrete production is a process whereby mixing and transportation of concrete can be combined together, and the product is delivered to the site at times right into the mold straight away. So, therefore, it combines mixing and transporting, can combine mixing and transporting, and it can deliver. So, you have a plant, batching plant, which is far away. That is what we discussed, the batching plant yesterday. The mixing and the batching is done at the central plant, can be done at the central plant, and then it can be transported and delivered straight away to the mold or close to the mold, or it can be pumped directly from the truck output, from the discharge of the RMC truck. It can be simply pumped into the mold itself. So, that is what is defined as ready mixed concrete. Now, Indian standard IS 4926, it defines ready mixed concrete as concrete delivered at site or into the purchaser's vehicle in a plastic condition and requiring no further treatment before being placed in position in which it is to set and harden. So, no processing is required. It can be delivered in plastic condition, and it will not require any further treatment, being placed in position in which it is set and hardened. I mean, the compaction obviously would be required. So, that is ready mixed concrete definition wise, and there can be, first of all, mixing can be done at while transporting. Some plants which are called central plant. So, you can have a central plant may have mixing in the truck. So, batching is done at the plant and mixing can be done on the truck itself fully, and such a vehicle would be called a truck mixer, like the one shown here, which will have a water tank and of course, the mixing vessel or mixing drum on which mixing will be taking place, and you have blades inside, baffles which will cause the mixing. So, whole mixing will be done here. So, in between, what you can do is the batching can be done quite early, and it is the truck will carry the ingredients in right proportions, and somewhere during the transit it can start mixing. Obviously, since mixing requires a lot of power, then the payload of the truck is likely to be less, plus also it has to carry the water separately. So, this is it is not only cleaning water, but mixing, this is mixing water tank, and these are the discharge chutes this is discharge chute, and you know this is actually for in inlet hopper through which your ingredients are put in. Okay, so this could be a truck mixer. An agitated truck might look something like this. So, which does not do mixing. So, mixing at the plant, batching and mixing at the plant, and it only simply agitates the concrete to keep it plastic and then delivers to the site. So, you can see that internal construction somewhat. There is the spirals through which actually the blades, and then this is the of course the outer peripheral drum periphery, and then tank for cleaning essentially, since it is an agitated truck. So, this is cleaning water only, it is just for cleaning, inlet hopper and discharges through this. So, agitated truck only agitates and its RPM is much less, you know, around 3 or so, 3 to 4, whereas mixing could be 7 RPM and so on. So, batching and mixing at the plant and only transporting, and during transportation it keeps on agitating the concrete here, keeps on agitating the concrete here, you know, keeps on agitating the concrete here. This concrete is agitated, this concrete is agitated, you know, it keeps on agitating the concrete that is here, you know, this concrete is agitated. So, that is agitated truck. Now, modern ones would be actually combinations of all. It can, you know, there is usually some mixing can be done. So, typically a truck would look like this. Now, you can see that there is a sort of a kind of you know cloth cover here. It's basically sort of a Hessian type of cloth, jute or similar sort of thing, which can keep a lot of water absorbed. This is covered, the drum is covered with that. The reason being, this is in the hot condition, tropical condition of Delhi or in northern India. So, this is kept wet, so that inside material does not get heated up because of the radiation and the temperature outside. So, that is a truck that you can see, and you can see the hopper, you know, this is the discharge hopper, the inlet hopper, and the truck as we have seen earlier. Inside there will be baffle and mixture. So, this could be agitator come mixing also, they can mix both, rotation capacity should be there. Typically shrink mix concrete, that means it is mostly mixed in the plant, and then if required some mixing can be done at the site as well. So, this is another view of the same one. You can see the discharge chute easily, this is the discharge chute, and this is where through it is getting it will get loaded, and the cleaning water tank is here, the cleaning water tank is here, and you know this is what you see in most of the places. Some of the trucks are like this. So, there is an extra chute through which discharge can be, you know, you can enhance the chute which can be connected here, and discharge can take place here. Generally they call it transit truck mixer or transit mixer, this is what they call it. So, this is getting loaded, actually it is getting loaded through the hopper, it is getting loaded through this hopper, concrete is getting loaded, you know, this is through the hopper, it is getting loaded, sorry, it is getting loaded, not this, this is a silo, concrete getting loaded through this hopper here, you know. So, this is actually getting loaded, and next diagram would show possibly this is showing the inlet and the outlet chute. So, which it is actually discharged into a pump that is standing here, as you can see it can discharge into the pump, and there is another truck waiting in the line next to discharge, and so on and so forth. The major issue is the uniformity of the concrete and loss of slump. Since you are transporting it and agitating it, uniformity should be maintained. and loss of slump should not be there. The setting characteristics of the concrete, while setting characteristics of the cement is one issue, setting characteristics of the concrete is the other issue, which is related to slump loss, because you add admixture. So, it is not the cement setting, it is related to cement setting, but it is something more than that, because not only the setting of cement, but then you are adding some kind of admixtures. If it is a retarder, it might make the setting time longer. Concrete will set for a longer period of time, set after a longer period of time, and if it is an accelerator, it will actually make it to set much faster. So, slump loss is a major issue, one of the major issue, that is because you make it to transport over a long distance. Now, most of the codes what they do, they actually restrict the time of haul to 1 to 2 hours. Of course, depends upon the ambient condition. In a hot, warm condition, higher temperature, time of haul could be lesser, because setting would be faster, and that is why there was a cover. You might cover the drum white colored. In this case, it was some sort of a Hessian type of cloth which was shown here, and the maximum number of revolutions sometimes is restricted, or most of the code actually restricts. It is at the mixing speed of the mixing drum is limited to 300 revolution at agitating speed, and at mixing speed 100. So, 100 revolution maximum or 300. So, 1 to 2 hours or 300 revolutions at a RPM of 3 to 4, which are agitating RPM, and at about 7 or so, which is actually mixing RPM, there it is restricted to 100. So, otherwise there will be sufficient loss of slump. Now, typically the slump loss might look like this. Typically slump loss, like some results shows this loss on slump during agitating at 4 revolution per minute. But this is some work done pretty early. If you see current ones, it might be quite different, because you can have retarders which can actually prolong it, but not 100 mm slump coming down to nearly 0 in about 6 to 7 hours, but there will be some loss of slump that is possible. Now, if you want to take care of this, what you can do is you can keep the initial slump high. You keep the initial slump high such that when it reaches to the site, actual slump is desired sum, or whatever it you are supposed to deliver, slump at the delivery. So, initial slump can be kept high. Other way is to use retarder, which will prolong it, but keep the initial slump high, retarder will prolong it. But if there is somewhere there is a traffic jam or something, and the truck is actually stuck, then in between adding water just like that, without any kind of experimentation done early, or without by default, if I may say so, or adding admixtures, this would not produce an engineered concrete. If it is known that you have to have a longer period of time of travel, and you may have to add some kind of a retarder in between and re-agitate it, then this must be first checked at the plant level, that how much will be the loss of slump otherwise. Now, negative effect of adding admixtures of water is loss in strength. For example, if you look at this, this will show you kind of loss in strength. So, the number of data which are there, and it will depend upon, of course, the temperature. So, if it is lower temperature, it strength loss, depending upon temperature of concrete, this was a diagram of 32 degrees centigrade. So, it will depend upon temperature as well as how much water you have added. So, if you add water, there will be strength loss, and as much as if you have added 50 kg per meter cube. In some cases, an example, typical, it is not all the time. So, if you add 10 kg per meter cube or 20 or 10 kg, you can see about 5% loss, 20 kg maybe 20% strength loss, and 30 kg somewhere around 30% strength loss, So, percentage strength loss could be higher. So, by adding water or retarder, again it can, of course, retarder can have other kind of effect also. It might result in segregation and similar sort of problem. But so, adding retarder in between by default is not the best thing to do, and it should not be left to the truck driver or somebody who is not very qualified. If it is to be done, because of traffic situation or similar sort of thing, this must be actually done earlier in the laboratory, simulated and do a test and see what happens to your strength if you have added an admixture in between, if you have added water in between, obviously the strength will be reduced. So, if you have added admixtures, what is its effect on strength? What is an effect if you add even some water, it will also affect your strength, because water cement ratio is likely to change. It might increase the slump. So, what you do? You actually design for a higher strength, that even if there is some amount of strength loss, finally the strength at the delivery point, the concrete which will be there at the delivery point, this must actually produce, this must actually yield same strength or result in same strength what is desired. So, this is important to understand. By default, things should not be done, it should be done by doing an experimentation earlier if there is an extreme case of traffic situation, which is quite often happens in Indian scenario. And but just like that, without any kind of testing, without any kind of pre-verification, admixture should not be added, neither one should add water and remix it, because there will be strength loss. You might get the slump back, but there will be strength loss. So, this point has to be kept in mind. So, two issues are very important: uniformity of the mix, which I talked earlier. Yesterday I talked about, last class, last module we talked about mix, uniformity of the mix produced from a mixer machine. So, you have to see that the RMC delivery of the concrete from the RMC truck is as uniform as possible, and we should check from time to time the uniformity. So, this is one issue. Loss of slump is the other issue which one must tackle in case of ready mixed concrete. Now, ready mixed concrete gives you a big advantage because it is done at the plant. So, since you are doing at the plant level in a factory sort of a situation. So, actually if it is done in a systematic manner with a batching, in a batching plant, or it is almost like a factory like situation, although modern precast industry will have much more sophisticated system, but ready mixed concrete, if it is done in an engineered way, it can give you much better quality concrete. But if it is done again not in an engineered way, like mixing admixture any time, not checking, continuously monitoring the results that you are obtaining, then it is again as bad as manual construction. But it gives you a chance to actually make concrete quality much better and much faster. Of course, done it simply you can do away with the space in the site, storing at the site, and if you look at the cost, even if it is slightly costlier, there is no problem, because the cost of aggregates and cost of storing the aggregates, cost of getting the aggregate, cost of inventory management, purchasing, etc., all these are reduced. So, all these costs should be taken together if one is like one would like to compare the RMC cost with the site mixed cost. Anyway, the quality question is very much there, and therefore, RMC is always a preferred situation than a site mixed concrete, because space and everything put together, and small quantity of concrete in large number of places one single RMC plant can deliver. But it has to be engineered concrete, must be done in an engineered way, in a systematic engineered way, and not just manually, almost like manual treatment, same treatment as the manual concrete should not be given. Should be handled with knowledgeable and qualified people. Quite often this this point you cannot ignore, because if you want to maintain the good quality of concrete, people should be knowledgeable and all systematic procedures should be installed. So, that is about RMC. The other kind of, now we can look into other kind of transporting methods of concrete, and obviously main issue of course remain that it should, during transportation, it should not segregate. So, basically handling tends to produce actually segregation and loss of slump, especially when distance is long, and that is to be seen. The RMC of course combines some transporting together with mixing, but there kind of other kind of mixing procedure can be adopted in large site especially, and even in sometime in small sites. Today in a mechanized process, many of those transportation method which I am talking about may not be, may become redundant, because if you use a pump together with truck, transit mixer and so on and so forth, most of this can be eliminated out. But however, some cases one may have to go to various kind of methods, one have to adopt various kind of methods for transporting concrete. Okay. So, whichever method is being selected, one must see that there is no segregation. Therefore, method of transporting and placing concrete which permits the use of most the driest mix, drier mix, that has to be better. Now, one issue related to of course adoption of pump is that the concrete must be pumpable, but if it is not pumpable then you can't pump. So, one of these methods you may have to adopt. What are the methods? These methods are discharge directly into forms through short chute or for a very small lead manually in containers. Not the best thing, not very desirable thing, short chute is a better one, manually discharge is not the best thing, right. But even if you have to do really, then certain precautions are to be taken, we will go through this. By barrows, wheelbarrows and hand carts, these are the wheelbarrows and hand carts, these have been used for quite often earlier, and power barrows or power bogies, then dumpers and trucks. Now, non-agitating trucks are not the best thing to do, it should be agitating trucks, but we will look into some of them quickly, the process. Then you have monorail, elevating tower and voice, buckets or skips operated by cranes or overhead cableways, belt conveyors and boom conveyors. Then you have got agitator truck, we have already talked about. So, these are the kind of methods we have, and tremie is used underwater or somewhere in the deep trench. Concrete pumps and pneumatic placers are the other ones which are used. So, let us look at some of the issues related to the former ones, that is our discharge directly into forms. Discharge directly should be avoided as much as possible. Concrete should not be dropped more than 2 meters, because if you drop the concrete from a height, and especially if the mix is dry, larger particles has a tendency to go further away. For example, all the large particles will have tendency, supposing you are dropping a concrete full from here, you are trying to drop them. Now, large particles will have a tendency to come here, smaller paste will have a tendency to fall here. So, large particle go there, large particles. So, it is desirable that this height should be less than, height should not be, h should not be less than, h should be always less than 2 meters. I mean h should not be greater than 2 meters. So, it should be always less than 2 meters. So, because if you are dropping from a larger height, if the tendency is to have larger particle will have a tendency to go further away. So, drier mixes, this situation is more prominent, and therefore, direct discharge. So, a chute is a better one, which is nothing but will have a cross section like this. A chute will have a cross section like this, chute will have a cross section like this, as we have seen earlier, and it may be something of this kind, metal made of mold. So, this is something of this kind. So, through a chute one can discharge first to the chute, and which is on a slope, you can discharge through that. So, if the height is say more than 2 meter or even somewhere around 2 meter. So, discharge through a short chute is usually better. Long chutes are not very good, they might cause sticking of the paste there, and larger particle again may go away. So, this is discharge through the chute. Wheelbarrows is one thing must remember, the whole load from the mixer machine should go to the wheelbarrow. We will see that there is one slide later on in do's and don'ts of concrete. In case of small mixer, whole load should go to the single barrow. Earlier power barrows were used, same thing, and people have used dumpers earlier, but today it is largely agitator truck. It is better to keep on an agitator truck. What happens is, in case of dumpers or trucks, you see, if he is going over the rough road, there can be jolting, even if it is pneumatic tire. So, if there is some amount of jolting, then what will happen? This jolting results in segregation. Larger particle will jump up while paste will stick, and then larger particle will tend to separate out from the paste, because paste should have, it is by this kind of jolting action, paste and larger particle tend to separate out. So, as a result, dumpers or non-agitating trucks are not preferred, especially the road is rough. Agitating truck, of course, manages to agitate and keep them together. So, that is using a truck. Monorail systems can be used over large slab. It can discharge on both the sides if it is travelling over the slab or similar sort of system. In a precast factory, this might be useful. Elevating towers and hoists, they actually lift the concrete up in buildings or sometime in bridges. So, you will have to have buckets through which concrete could be lifted up, and then if it is also a horizontal travel, then the bucket has to be unloaded somewhere, maybe onto a barrow or something, so that horizontally concrete can be moved horizontally. So, elevating towers and hoists transports the concrete only along vertical direction. You need something else for horizontal movement, right. Monorail, of course, also can have little bit of slope, but usually it is on slab or flat surfaces. In cast, precast situations, it has found its use. Skips operated by cranes or overhead cableways, buckets essentially operated by cranes. So, crane has got both horizontal as well as vertical movement. Over a particular radius, it can deliver concrete both horizontally as well as somewhat vertically, but there is a limitation depending upon, of course, the type of cranes. It is a tower crane, then it can actually transport quite a bit both horizontally as well as vertically. Overhead cableways have been used in river valley projects, to transport concrete from one bank to the other bank or over the somewhere over the river itself. So, these are but you need again buckets and can transport through the using the buckets can be transported. Belt conveyors or boom conveyors. Boom conveyors are actually used along with a tower crane. So, concrete can be lifted up through hoist or towers and discharged into a container in a boom or in a boom conveyor. Through the conveyor, concrete can be transported at different places, and the boom conveyor can actually rotate and move, and therefore, over a circular area it can spread the concrete. Belt conveyors are also used from point to point actually, but one thing in both these cases, over the rollers of the belt moves over the roller, and as it moves over the roller, there can be jolting action, because it would actually belt moves like this over roller, belt moves over rollers, belt moves over rollers, something like this, then there is another roller. So, as the concrete, and there are concretes here, this is the section as seen from this direction, So, these are your concrete, it moves. So, as it moves over this roller, there can be some jolting. So, and this can result in segregation. Besides, the slope is restricted. It can transport the concrete through slopes of about 15 degree, maximum 20 degree or something of that kind, not very stiff slope, it cannot transport concrete, all right. So, this is conveyor belts which have been also used in some cases. It is still used actually, if in for example, if you are making the lining of a steel pipe, usually pipes which carry water, steel pipes, there is an inside mortar lining or rich cement mortar lining or rich cement paste lining. Now, what is done is the belt conveyor takes the concrete right inside the pipe, it is like this is your pipe cross section, the belt conveyor, this is your pipe, steel pipe, right. Belt conveyor will move the concrete here and discharge. From the concrete will be discharged from here right away onto this one, and this spins. This of course spins, rotates, and by this rotation it transports the concrete or puts the concretes right up anywhere, and this through this process actually, or cement paste, not really concrete, cement, I mean mortar, rich cement mortar, this would actually be get spreading. Now, this conveyor can move inside, right inside, and then gradually shifted, and through this belt conveyor concrete is transported. So, pipe lining, one can use this conveyors. Many other places over short distance, not much slope, belt conveyors can be used, but they are very specific, not very common way of doing it, but they are also a method. This is also a method. Agitator trucks and truck mixer I have already talked about. Trimi is used in underwater concrete. We will have some diagrams and look at that. Pumps and pneumatic placers, these are the most commonly used, and we will devote a complete separate lecture on this particular one. And you can use any combination of the above, because if it is to be, for example, in earlier days, let us say you have a high level bridge. So, the bridge deck, something like you have a bridge deck, you want to do some casting. So, you have something like this is your pier, and there is a pier head, and pier head is here, and bridge spans along this direction. It spans along this direction, right? It spans along this direction, it spans along this direction, all right. So, this is something like this, the girder system, box girder maybe. So, what you do is, over the pier head, actually there is a center point, you have to lift the concrete and transport. So, if I see it like this, this would be my, if I see it like this, this would be my deck system, right, on this side, and I have a tower here. So, I lift the concrete through the tower, transport it along this direction. If I am to cast some segment here, let us say I am casting some segment here. So, I need two methods, combination, that is a tower through which I lift the concrete here, and there is a wheelbarrow or some sort of transport, horizontal transport to take the concrete at this point. So, this is in case of a bridge, and this is very common in building too. So, you may have to actually use combinations. So, combinations are used, any combinations depending upon the situations. So, any combination depending upon the situation one may use, right. Let us see some of them in more details. Something to do with the manual transport, free fall of concrete over a height of 2 meters is to be avoided, that is what I said. It cannot drop concrete more than 2 meters. Short chute with proper lower end treatment are simple to use and economical. Short chute can be used wherever required, and that is it can actually last for a large number of repetitions. Steel chutes, metal chutes, it is a semicircular cross section, simple semicircular cross section apart, you can half cut pipe. If you have a pipe, you just cut it half, something of that kind, but it is not usually pipe, it is a metal bent. So, something of that kind, metal steel bent chutes can be used, and they are very useful, because over short distances, supposing you have a trench or you have the foundation of which is slightly below the ground, footing you want to cast, and you want to drop the concrete from the top. Now, if you drop it, you do not drop it more than 2 meters, because relatively dry concrete would have a coarse aggregate in relatively dry concrete would have a tendency to go further away, while paste will have a tendency to remain. So, it causes a kind of segregation, but short chute, if it is dropped onto the short chute, it goes down through the gentle slope, actually the larger particle will still be sticking to the paste, and so on and so forth. So, short chute is fine. Long chute, there can be a problem, because some paste will in the long run it will tend to go dry, and at the end it may actually cause the paste to remain sticking. Very long chute should not be preferred. Manual concreting, therefore, this 2 meter height one should keep this. For example, this is what about the chute, it is metallic, half round in section, stiffened at places, may last to handle about 1500 meter cube of concrete. So, chutes are almost is a must. Even if you have all other mechanism of transporting concrete, sometime you may have to use a chute somewhere in the concreting. Long chutes are not desirable. So, this is one major issue one must look into. All right. Then buckets and skips, these are most important. Well, two types of buckets have been actually used or proposed, but this is not very common. One is rollover, other is constant altitude type. They are actually designed bucket. There are other kind of buckets which are used, they are not the best one. But instead, I did not discuss much about the monorail nor about the cableways and all that, but I choose to discuss buckets or skips because they are used quite often, most commonly used, and you have to combine them together with your tower or anything else. Many places you have to combine the buckets and skip. Even if you are using a crane, you have to use a bucket and bucket. If you are using any kind of transportation method, you have to use a bucket. So, there are two types of buckets one can think about. One is called a rollover bucket, other is the constant altitude type of bucket. These are absolutely designed bucket for concrete transporting and placing. The capacity of course can have 0.2 meter cube to as large as 10 meter cube. Now, 10 meter cube to handle it accordingly, 0.2 meter cube is a small one, and they would look something like this. Okay, as we shall see later on. Control of discharge is obtained from good design in terms of shape of the gate for proper flow. The ease of filling should be there, and resistance to wear and tear are other aspects of good design. So, essentially discharge, control discharge control is very important. Gate shape should be very important, and it should have proper flow, but while filling it should be very easy to fill, and it should last for a long period of time, right. Buckets are also used for underwater concreting, we will come to that sometime later. So, the two types of buckets I was talking about, this one is rollover, it is actually rollover, right, and what it does is while lifting it is like this. So, this is the position while lifting, right, where is a position while lifting, while loading its position is something like this. So, this is the one it gets lifted. So, you actually load it through this actually load it through this, and concrete gets loaded here. So, it gets loaded there. This mechanism is essentially meant for lifting it up. So, bucket shape is something like this, and then as it is filled in, this is lifted like this. So, discharge is from this bottom, discharge is from the bottom opening, you just make it to open, and this is discharge is from bottom opening. So, this is rollover type, one can use them. So, it can roll over. This is constant height. So, this height is constant, this can go down a little bit, but this is the height of the bucket. This is actually the height, and when it is lifted, you can this can come down. This is the lifting mechanism. This is simply for lifting, right, this height, and this is the bucket gets supported on this frame. Bucket is supported on this frame. This is actually the bucket, the concrete will be inside, the black portion is the concrete. So, concrete is inside. So, while lifting, this is while in position, while loading is from the top, the bucket is in this position, it is simply supported on this frame, and while lifting you can simply lift from this position. Now, you can see that it is wide open, this has to be wide open, here also this has to be wide open. So, buckets main thing is this is two kinds of design actually, but there can be various other kind of design possible. Essential requirement is this should be wide open as possible, and should not be very narrow and not in one corner, because if it is wide open and bottom opening type, that is much better. So, this can be opened by, let us say, first you close it, then load it, and when it reaches, the concrete reaches, simply the gate here can be opened. It might be hooked or some sort of mechanism. Now, conventional sometime people would use this kind of buckets, large cylindrical bucket with a hook, and just tilt it to discharge, tilt to discharge. That means, it will take a shape of like this while discharging, and manually discharge, take a shape like this. So, while it is in some position here, because it is being tilted, large size aggregate will have a tendency to go. This is not the best way to do. So, discharging from the top is not desirable, not desirable. Discharging from the top is not desirable, tilting this one and actually discharging the concrete is not desirable. It should be bottom, it should always be bottom, discharge should always be from the bottom, because if you try to tilt and discharge large aggregate, if the concrete is a little bit dry, not pumpable or self compacting concrete, that concrete of course does not require all this, but slightly drier concrete, if you are trying to tilt it, the large size aggregate will have a tendency to go further away. So, large size, large aggregate, smaller aggregate and smaller mortar, aggregate and mortar would have a tendency to remain close, because you are tilting. So, large particle will go away, space to, and you will find there is a segregation at the point of discharge. So, this has been used quite often, sometimes these are used, but that is not the best thing to, do. One should be using bottom opening bucket, and large opening. For example, this photograph shows a bucket here. So, this is the bucket, but this is not a very good bucket. You see, it is inclined, although the opening is here, it is actually a forklift which has lifted it up, and it is being concrete is being transported using forklift. It will be discharging somewhere ahead, right. So, forklift transport, that is not the best thing to do. So, this bucket actually, while onto the ground, it is supported like this, it simply supports here, but this inclined discharge is not the best thing to do, and this should be narrow. So, while inclination in the discharge, actually paste would have a tendency to block here, clog here, and that is not the best thing, that is not the best way to actually discharge concrete. It should be bottom open, wide open bucket, For example, this one is discharging somewhere there, it is actually discharging concrete somewhere into this mold, and this is not the best bucket as possible. Discharge is through this particular end, and it is not this position, and it is not the best thing to do. It should be bottom open, preferably, and with a wide opening, so that, and the gate can be closed and opened easily and smoothly, most of the concrete should discharge. So, this was related to buckets. So, important point is that if one is using bucket, and which are very commonly used means of transporting concrete, one should be careful, because segregation is the major issue. So, while transporting concrete, one has to be very careful. Segregation is the major issue, as I said. If the bottom is narrow, nothing will pass through it, possibly only paste will go, aggregate will go much later. So, narrow opening should not be there, large opening and bottom opening, should not be tilted, because tilting can result in segregation. So, you will have to remix it again, etc. So, this is very important. Now, one important place we would like to look into while transporting concrete underwater placing of concrete poses actually a number of problems. You cannot compact the concrete, and concrete may get mixed with water. So, whenever possible, underwater concreting should be avoided. This is not connecting, this should be concreting. Underwater concreting should be avoided. This should be avoided actually, underwater concrete should be avoided, this should be avoided. Well, today you have self compacting concrete, so you can actually go, compaction may not be an issue, you can pump the concrete, so that also may not be an issue, but still mixing with water, getting mixed with water, that's usually an issue, So, there are many ways of doing it actually, underwater concreting. Concrete must be self compacting and wet enough to flow under its own weight, and must be placed with least disturbances, must be placed with least disturbances. One may use what is called an anti-washout admixtures. One may use what is called an anti-washout admixtures, which actually thickens the concrete, sort of something similar to what is called viscosity modifier. So, that would ensure that it does not lose much of the cement, it does not lose much of the cement. So, one of the ways of course is use pre-packed or grouted concrete, trimmy or bucket, as you shall see, pumping and dumping by bags. Now, grouted concrete is pre-packed or grouted concrete is see this well foundation, we do something called bottom plugging. So, well is sunk. Once the well has been sunk, boulders are dumped, right? Boulders are first dumped. So, you dump the boulder, then lower the pipes, simply grout pipes, and they actually first pipes are lowered and then the boulders are dumped over it. So, just see how it looks like. It would be something like this. You have a, let us say you have a well, you dump is the bottom of the well, let us say, and you dump the boulders of different sizes, up to certain height, which you can be found out by what is called sounding. Then pipes are already there in the beginning, pipes are already inserted there, fine pipes, grouting pipes, and they go right up. Then inject the grout through this, the grout under pressure. So, grout under pressure goes in and it gets spreaded inside and then makes this grouted concrete. Now, this is what is used in bottom or top plug of well foundation, because in a river for a bridge you use a well foundation, there will be water. Well foundation, inside the well there is water. So, what is done is once the sinking of the well is over, you do what is called bottom plugging. So, actually make it heavy, stability, as well as put make a kind of a concrete there. So, first put down the pipes, grout pipes, and reach cement 1:3 cement mortar you use with it's a, but then it has to flow. So, therefore, a lot of water, sometime one can use actually plasticizer and any other kind of admixtures actually, shrinkage compensating maybe, but that is not used. Usually one may use a plasticizer or generally simply the grout, using a called grouting process as it is called. So, basically grouting you do, so it actually plugs up the bottom. Then you fill in soil here, soil is filled in here, and then you do again what is called a top plug. So, what you do is again a top plug. So, top plugging is done here, top plugging is done here actually, top plugging is done here, top plug you do here. So, you do top plugging, again boulder dumping and same thing. So, this is the process by which actually you do underwater concreting in case of well foundation, and that is essentially using the kind of grout that I talked about. Now, dumping by bags is also possible. It is also possible to dump by bags. It is also possible to use bags and dump it by bags. It is also possible to dump it by bags. So, what you do? Put the concrete inside bag and just simply dump it. Now, then you are doing it, what you are doing? You are actually some place where you are just filling in concrete with the bags. So, the bags keeps the concrete away from the water. Not it can be done somewhere where the shape of the things are not very important. You just want to dump some bags and that is okay. Pumping can be done, and the nozzle of the discharge nozzle must be always below the concrete itself, Trimmy concrete is very common in trenches, and that is what it will look something like this. Trimmy concrete is it would look something like this. So, let us see first the buckets, and then now underwater buckets could be of something of this kind. Underwater buckets could be something of this kind. This has got a skirt, it has got a skirt. right, a canvas cover and the skirt. So, you have a bucket which is a bottom discharge open, that means it will open like this, this is a bucket in closed position, and while opening simply this will get opened like this bottom will open like this, you see this portion has opened. So, bucket is something like this, bottom opening complete is lifted up like this, but there is a skirt outside. So, this skirt normally as you are transporting the concrete, it is up. So, once this portion goes and touch the bottom like this, at the bottom, the skirt actually will open up and concrete is discharged within this skirt. So, concrete is this is the open portion. So, this is concrete, this is the concrete, and concrete is discharged within the skirt. So, that it does not get mixed up with the water immediately. So, this is one way, it will depend upon where you are using. So, this one first, this is the way they are filled and you are lowering, and this is the discharge. So, this is the discharge. So, bucket, but more common is what is called trimmy concrete, a trimmy process. Now, in a trimmy process is actually done in trench, and anywhere actually, anywhere anywhere you can do it. So, in trenches for example, or let us say piles, cast in situ piles, in cast in situ piles you first you drill the borehole and then put bentonite slurry to stabilize the water around, and then dilute the bentonite and put the trimmy pipe inside, trimmy pipe inside and discharge. Now, one thing, the pipe bottom must be inside the concrete, Here also it is actually this pipe bottom must always be below the concrete. So, first is prepared surface to receive concrete, well there can be some preparation or whatever it is, and end of the trimmy is continuously below the top surface of the concrete. So, to start with actually what you do, to start with a little bit of concrete, you put the concrete actually a little bit, but that concrete will be it forms a heap, but concrete some of the concrete will actually come in contact with water, but later on you have always the bottom of the trimmy pipe below the concrete. So, this portion if it is discharging, actually concrete will build up from here. Now, this surface is in contact with water, this surface is in contact with the other. So is the case here, the top surface of the concrete is in contact with water, rest of the inner concrete will never be in contact with water, right. And this pipe once it is filled in, let us say once you have filled in the concrete up to this, you lift it up. So, there is you can lift it up, and it is flange pipe. So, there are flanges, you make connections, there are segments or sections. So, you make connections, and as you make the connections through the flange, gradually you lift it up depending upon what is the how much of the concrete has been placed. So, lift it up, and there is of course a hopper through which concrete is dropped, but dropping to the depending upon the height, if you drop it from too much of a height, I mean dropping height should be through a chute actually. So, you have a chute through which you drop the concrete, and the concrete comes down below the surface. So, this is the hopper, and gradually you can lift it up, remove the hopper, remove one of the segment of the pipe, connect the hopper back, and so on and so forth. So, concreting can proceed in this manner. So, this is a special case of concreting, below the water. Well, today of course, you can simply put the pump, the hose of the pump and its nozzle just at this position, and you are not compacting the concrete. So, concrete should be as flowing as possible. In good old days, people would make it a very high slump and also use very low water cement ratio, essentially to see that, because water cement ratio is might get disturbed. Modern days of course, water cement ratio still is an issue, you can keep it low, but one can use the pump or self compacting sort of concrete or pumpable concrete, which will go inside and which will actually flow. So, that is actually related to high underwater concreting or concreting in tray. So, we have discussed actually most of the method related to concrete transport, transporting concrete, right, and also before that we looked into transportation by ready mix concrete, trucks, which actually combines the mixing as well as the transporting process together, right. And most commonly used today, of course, is a combination of truck and agitator truck and pump. Now, we will discuss about pumping of concrete in our next module, next lecture of the same module. And today, of course, we have discussed all the methods of transporting concrete and ready mixed concrete. So, main issue while transporting or even transporting through ready mixed concrete is essentially two issues. One is a segregation, concrete shall not segregate in any manner, and other issue is related to loss of slump while transporting. So, it should not segregate, because placing of concrete should be within the initial setting time of cement, of course, but then the setting time of the concrete. Setting time of the concrete can be different than the cement, as I said, because I can add a retarder or some kind of plasticizer retarder combination, which would actually delay the setting of the concrete itself. So, I must place it within that period of time, the dormant period which you discussed right in the beginning, the reaction dormant period during which actually cement hydration reaction takes place, and it goes from the plastic state to the solid state. So, during which I should do it, and then it should remain cohesive and should not lose its uniformity as far as possible, no segregation. So, this is what we summarized today. Transporting concrete, we looked into all mainly we looked into the names of the methods, some we discussed in details, and followed from this we will be discussing about pumping in our next lecture. So, thank you very much.